In 1903, the Wright brothers' invention, the airplane, took flight. Military applications of this technology required imagination. At the beginning of World War I, aircraft were used mainly for surveillance. As the war progressed, they were also utilized as fighters and bombers. World War II ushered in a new generation of aircraft and tactics. Japan's attack on Pearl Harbor and Doolittle's strategic bombing raid on Tokyo are examples. In the Battle of Britain, the German Luftwaffe sought to use strategic bombing to control the English Channel as a prelude to invading England. The introduction of radar for detecting aircraft gave the British a necessary advantage that helped them turn back the German air assault. Teams of British civilian scientists, mathematicians, and engineers explored how to best use information provided by this new technology, radar, to deploy their fighter planes to counter the German bombers. This research on military operations grew into the scientific discipline now called operations research, or just OR. OR techniques were instrumental in devising radar and fighter plane responses to the Nazi air attack. During the Cold War, aircraft such as the U-2 were developed and deployed for long-endurance intelligence, surveillance, and reconnaissance missions over the Soviet Union and other communist countries. In 1960, Francis Gary Powers' high-flying U-2 was shot down over the Soviet Union by a surface-to-air missile. This demonstrated the increasing power and capability of integrated air defense systems, as well as the intelligence and political costs of losing a pilot and an advanced aircraft to the enemy. To defeat radar-based defenses, aerospace designers experimented with a variety of low-observable aircraft designs, such as the Have-Blue prototype and the F-117 stealth fighter. Dr. John Cashin of B-2 stealth bomber fame captured the essence of stealth in his formulation. Stealth equals low observable design plus tactics. The tactics are detailed route plans that maximize the LO nature of the aircraft. In the mid-1980s, the founders of what was to become Orca worked on route planning tools for the B-2. Eventually, they designed Opus, a route planning tool for LO aircraft, which uses sophisticated routing algorithms and modern computer technology to produce optimized routes. The success of Opus fast auto-routing technology has opened the door to several aspects of military aircraft mission planning. First, there is ground-based pre-mission planning. This entails auto-routing to produce optimized route plans for vehicles performing a predetermined set of mission tasks. Traversal and analysis tools provide the planner with the confidence that he has planned a good route. A second aspect is in-flight replanning. Once aircraft are airborne, changing conditions may make it necessary to generate new route plans. The speed of Opus makes this dynamic in-flight replanning possible. Analysis and studies represent another aspect. Fast route planning is invaluable for analysis of strategies and tactics, studies on topics such as the value of stealth and the design of new aircraft. The data-driven nature of Opus allows analysts and designers to perform what-if studies. The ability to generate large numbers of routes quickly allows analysts to produce a sufficiently large sample for statistical analysis. Automated mission planning is important for unmanned aircraft to achieve appropriate spans of control. The auto-routing and in-flight replanning tools embodied in Opus support the types of semi-autonomous and autonomous operations now being conceived for unmanned vehicles. Command and control applications for mission planning are numerous. Force-level planning implements decision-making for groups of aircraft, conventional and low observable, manned and unmanned, deciding which aircraft should perform what task when. This force allocation process has a role in both pre-mission planning and dynamic replanning. Allocating aircraft involves generating multiple route plans, possibly in the hundreds or thousands, for evaluation. Fast auto-routing technology is essential for this step. It is the nature of war and of history that there will always be new technologies and new problems employing those technologies. It is only fitting that OR concepts applied to the problem of evading radar are just as important as those that were applied to the problem of deploying radar during the Battle of Britain. In the future, we must be able to provide quick-running, effective tools to support military decision-makers in addressing problems of increasing complexity.